Hi students, welcome to Year 10 Science and the motion and energy topic. In this sixth video we're going to be looking at Newton's third law. So we've had a look at the first two of Newton's laws. This one's probably the most well known, I guess, of the three, because everybody knows about action and reaction pairs. Formally, Newton's third law states for every action force there is an equal and opposite reaction force. One of the simplest ways we can demonstrate this is simply to look at a box sitting on a table. Now, what we often think about is the fact that this box has a mass, and therefore if it has a mass, then it's also going to have a weight. Weight is equal to mass times the value of acceleration due to gravity. From the last video we saw that F equals ma. So this is just an application of force, where force is the weight and m is the mass, of course, and the acceleration is acceleration due to gravity, and this gives us this little equation over here. Of course, the important thing is that the box is not actually going anywhere. In this case, there is an equal and opposite force that's being exerted by the table on the box. This is often called the normal force, normal. And the normal force is equal but opposite to the weight force. So we could actually talk about a negative weight, if you like. The fact that it's acting in the opposite direction to the weight force, but is equal to it in magnitude. Hence the box neither accelerates down, nor does it accelerate up. So here, in this case, we have an application of Newton's first law in that there's no net force acting. But the important thing to remember is that the box is exerting an equal force on the table as the table is exerting on the box. Make sure that this doesn't look like it's suspended in midair. Now, how to explain Newton's third law? Well, one of the important applications of Newton's third law is in rocketry. A simple way to look at that is what happens when we blow up a balloon. When we blow up a balloon and let it go, it flies around the room. We've all seen that effect. What happens is that the air is forced backwards out of the opening, and as a consequence of that, the balloon actually moves forwards. That is, some force is actually driving it forwards despite the fact that the air is moving backwards. So the air goes out and the balloon goes forward. These two forces are equal in magnitude or size, but opposite in direction. So they're acting equally but in opposite directions. So this means they form what we call an action-reaction pair. So the air, in this case, is the action. The air being forced out is the action, and then the balloon, or the air pushing on the opening of the balloon, is the reaction, and that causes acceleration. Okay, so the action force here, just that pushing of the air back, and the reaction force is the air pushing the balloon forward. Now, I mentioned right in the first one of these slides that we had the box sitting on the table, and the net effect of the box sitting on the table was an application of Newton's first law in that there was no net force acting. And that's why there was no motion. But one of the important things that we need to understand is that we're talking about two different things. So it's entirely possible that two objects of different sizes can both be moving and apply a force on one another. When that happens, the forces do not cancel each other out. What they do is each force acts on a different body, and as a result of that, they cause a different acceleration. One of the ways of looking at this is to look at ballistics. Most of us are aware that guns recoil. They move backwards when you fire them. So a bullet is going to move in a forward direction as it leaves the muzzle of the gun, and as it does that, there is an equal and opposite force back in the other direction. This is just the reaction force caused by the firing of the bullet from the gun. The thing that's important to remember about Newton's third law, and the thing that often people have trouble with is if you have a very large object like a truck colliding with a very small object like a car. When these two come together, they are going to apply an equal and opposite force to one another. The result of those force applications is that because the car has a smaller mass, it will have a larger acceleration. Likewise, the truck has a much larger mass, and therefore it's going to have a smaller acceleration. But the force that each applies to the other is equal and opposite. I've put a little table here for you so that you can just summarize some of the key ideas out of each of these laws. Now, there are some complex applications of these laws, and we really are going to need to go through a few examples of these in class. So perhaps put this table in your book, and in class we'll actually have a look at some of these complex applications of Newton's 3 laws. Thanks for watching.